Our next speaker is an accomplished software engineer with strong SDLC experience with a string of projects in the security domain. He always strives to build better software with extra focus on data security that would be kept throughout its life cycle and not just as an afterthought. He considers himself to be a perfectionist, yet remains practical, knowing where to draw the line and stop. Something that we all need to learn from him. But for now, let's all learn about security for cloud native workloads. Ladies and gentlemen, let's get the ball rolling and give a big welcome to Runcy ooman. Runcy, over to you.
My name is Runcy, and I'm like super excited to be presenting at the DevOps India Summit. Thanks for having me here, and let's get started with security for the cloud native workloads. All right. So this is sort of like my promise to you for the next 30 minutes, and we're going to get started with the generic cloud native and the cloud security overview, and then look at the shared responsibility model that's been much tutored upon by all the major public cloud providers. And so I'm going to dive into that. And then specifically look at the microservices security, and then look at the paradigms that's mostly popular in the cloud native world, that is with respect to the containers and the serverless mode of doing things. And then specifically look at the steps that we can actually do to secure the container lifecycle, and then dive deep into the Kubernetes security improvements. All right, so with that, this is sort of like a brief intro about me. So I work as a principal software engineer with SonicWall, got few certifications under my belt, also have a patent for the cloud security around the distributed data storage. And so that's like my career. And on my community front, I am the organizer for the GDG Cloud, AWS user group, and the Cloud Native Meetup groups in Bangalore. And I speak at regular conferences and technical gatherings. All right, so that's enough about me. And I'm going to set the tone by seeing what cloud native actually means. And I'm not going to read from here. All of you can read. And this is like a definition that I've taken from Wikipedia. And just look at the ones that I've highlighted or underlined, right? So it's basically about building and running stuff irrespective of where it is. So it could be public, private, or hybrid cloud. That is truly the cloud native thing. And it could be containerized, or serverless, and it could be like a microservices model, right? And the underlying part is the immutable infrastructure, right? So it's a way of doing things a little different, irrespective of where it is actually is, and the different paradigms in which it could be done, right? So we're going to be looking into that aspect. But to understand this, we need to have this fact, right, that the IT infrastructure and the landscape has sort of like undergone a paradigm shift. And what does it actually mean? Because when I started my career, right, in the IT industry, this is sort of like the diagram that the IT person gave to me, right? The big bad world of internet that is sitting behind a firewall, that is letting only the good traffic through to the glass house, that is the enterprise, right? But from this, it's now sort of like undergone a shift to this, right? The glass house is still there, but all of your workloads, right, whether it be CAS, PaaS, DaaS, FaaS, right, whatever it is up there in the cloud, because it's now become sort of like an organization lightweight to do things, right? So if this is the case, then shouldn't we be also looking at the cloud security a little different? Because if this change of workload has happened, the traditional way of network security doesn't even apply in the cloud, right? So there has to be a little different way of looking at the cloud security workloads. So to understand truly that, we need to know the different facets of clouds. And what are those? Because cloud is ubiquitous. It is everywhere. You can reach it from anywhere, any device, anytime, right? Cloud is scalable. Yes, with the push of a button, you can have unlimited amount of compute, storage, networking, or memory, and without even breaking a sweat, right? Cloud is highly integrated into the fabric of the organization, right? Because the services definitely talk to each other, and there cannot be like a cutout between your corporate internet and your other thing, right? So if even if there is something with the 4G and all the 5G that's coming up, you can definitely access cloud with just a hotspot. So that cutoff is definitely not possible. And it is comprehensive because the cloud can scan every byte, ingress or egress, and it is intelligent enough, right? I mean, if you've come from the AWS world, right, when the services got launched with S3 or probably SQS, there were like hardly two or three services with the EC2 and everything. But now if you go into the AWS dashboard, you actually need a scroll bar to see the list of services. So it is actually evolving and intelligent enough to understand the customer needs, and it's constantly evolving, and it's highly available. Yes, with the 11 nines of availability or durability that's been tutored by all the major providers, it is definitely available. So this is the understanding that I want to bring in, because the early days, the security was like about the second layer on top, right? You've had that agility or the height that you actually got from spinning up EC2 machines with just few clicks, and that height that you received. And the security was just probably something that you added on layer of top, right? But now the workspace has definitely changed. Everyone is on the cloud, and it's all about moving fast and also about staying secure. The security is definitely a top priority for everyone because the bad guys are always catching up with your workloads in the cloud. So this is definitely the modern way of philosophy of workloads in the cloud. So with that, what are the security checks and balances that you actually need along with the cloud features? We discussed about the cloud features earlier, but what exactly does go hand in hand with this? Because cloud, yes, it is agile, but you definitely need like a gatekeeper to actually make sure that the valid request and the responses are definitely being cut out, right? Cloud is highly serviceable. Yes, it is the main paramount important feature of the cloud, that you can actually go there and do whatever you want, but it should not compromise on the standards that's been kept. So the organizational standards definitely have to be in line with the self-service model of the cloud. It is scalable. Yes, we talked about it earlier, but it shouldn't compromise on the controls the IT definitely has to keep with it. It is automation everywhere. Yes, that is the main principle on which the cloud is being built, but it should be like a centralized place in which you can actually do the stuff in an automated manner. And the pay as you go model, that is the most revolutionary feature of the cloud, so to speak, with the serverless and all the other ones. You pay only for what you use. But at the same time, if there is like a spike in usage, you definitely need an alert and a monitoring mechanisms to basically check that cost. Right. So with that, let's dive into the shared responsibility model that is cutting across all the major providers. And the important thing to look at it is basically security of the cloud and security in the cloud. So what does it actually mean, right? So this clear distinction has to be understood when you migrate your workloads to the cloud. So the cloud is nothing but the famous joke, someone else's computer, right? So there are physical computers that are residing in the data center across all the world, right? So the security, the physical security of it, to make sure that the Cat6 cablings are there in the data center, to make sure that the perimeter security or the encryption that is being used within the disk, that is security of the cloud, and that is the provider's responsibility. But now, what do you mean by security in the cloud? You spin up a machine or a VM and you store your objects in the cloud storage, right? And making sure that there are specific access controls for those particular things, making sure that the ports are not open, making sure that the IP addresses are only accessible from within the network or from the desired target. That is your responsibility. And that is security in the cloud, right? So that is this clear understanding that we have to adopt as we migrate to this cloud with this overnight digital transformation that's happened because of this corona situation, right? So it's all the more important that we understand this shared responsibility more, right? So with that base understanding set, let's begin the journey from the monolith to the microservices, right? So what exactly do I mean when I say a microservice, right? So it's nothing but an application that's just broken down into little chunks, which are just calling another API endpoint or another API endpoint and so forth, right? So you would have these clients on the left side that are depicted over here. It could be web, mobile, tablet, or anything that's just coming out. Smart bulbs, for example, yeah, pretty much. And they call the front end APIs, which in turn communicate to the back end APIs, right? So it's sort of like a different services that creates a service mesh that is just calling it, right? And all of them are self-contained to actually do their tasks, and it involves some sort of like a high automation with the CI/CD pipeline, right? So gone are the days where you actually do all this stuff in one single stuff and with the heavy manual intervention or a human intervention. This microservices is sort of like a different paradigm shift, and it's sort of like a little different in which it is all the API endpoints and with the agreed upon request and the responses that are coming in, right? So let's take a step back and understand how we actually received it, right? Because and it is important to understand what the VMs and the containers are, right? Because when VMware introduced this VMs, it was sort of like a revolutionary change, right? And on the left side you can see that there is this concept of hypervisor on sitting on a very heavy beefy machine, and on top of that, there are these segregations that you actually do with the guest operating systems. And on these guest operating systems are your applications and your libraries. But with the container that's been announced by Solomon Hykes in 2013, so it's like a very new technology. What it actually means is you're removing that abstraction of hypervisors and the guest operating systems. But it's nothing but a daemon or a container daemon that actually acts and spins up your applications and binaries, right? So it's like a very smaller definitions and using up the resources that you actually know, right? Now here is like a good analogy that actually sets this definition further. So the glass bowl on the left could be your application, right? And the goldfish inside is the application, but the VM is the beefy VMs which is there, which is having excess amount of compute, storage, network, and memory. But on the container, it just spins up the required resources or the hardware resources just enough for your application to work. And hence, it is very easy to scale for using the same compute resources in a much agile manner, right? So this is this good analogy that I wanted to bring it up with the VMs and containers. So with that understanding that's been said, you want to now be thinking about how it can actually help, right? Well, this is definitely helpful because containers are definitely portable, because you can build once and run anywhere, right? This sort of like the idea that Java basically talked about, but that was with the JVMs and everything. But here is containers are portable. And now coming back, the portability defines on whether it is like an on-prem or on cloud, or if it is a multi hybrid solution, right? And it is scalable, yes, because containerized application offers the ability to handle and increase workloads automatically. And that's the high scalability that we actually talk about. And it enables for fast development because the development is much more granular. It is for developers, it's much easier to track and change the changes within that particular container. And then there is no excuse of saying that, hey, this works on my machine, but not on yours, right? Because it's the same stuff. The classic development excuse is no longer valid, and it allows for fast development and security, right? So there's this isolation that's been applied. It's very, I mean, I'm not saying that containers are secure. There are a lot of vulnerabilities that's being discovered in terms of container jailbreak and all the other stuff, but it's being improved upon. As I said, it's only like about 6 to 7 years since we are in this paradigm of development. But at the very base level, it's using the Linux C groups and namespaces concept. And obviously, it's been improved upon every day, and it helps for app isolation. And there is this continuity that is being there. Like it's there because the failure of one does not necessarily impact the failure of the other. So there is some sort of like a fault tolerance that's been built into this model of doing stuff, right? And it allows for easy management because with the orchestration that's been provided, it's definitely helpful in that aspect. And what does it actually mean? Because I've talked about the fast way or the functions as a service, but don't just think serverless is just fast, right? Serverless is this whole superset that is there, right? Whenever you put a object in Google Cloud Storage, right, that is serverless. When you're processing something of a huge chunk with a big query, right, that is serverless because you are only consuming the resources for what you actually need. And the FAS is the more popular ones like the AWS Lambda or the Google Cloud Function or the Azure Functions. That's just a small subset of the serverless pie, right? So anything for which you don't pay for the whole services, that is serverless, like the AWS S3, Google BigQuery, right? All of them are serverless services, the messaging services that are there. So it's very essential to understand this, and this is definitely the new paradigm and a very developer friendly way of doing stuff, right? So that's the basic understanding that I wanted to cover in terms of the containers and the serverless way of doing stuff in the cloud native world. And it is very essential that you have to secure all of these, right? And the stack in terms of this starts from the very basic one, the traditional hardware stack, which is consisting of the infrastructure services in compute, network, storage, and memory. And that responsibility should definitely be lying with the system admin or the IT ops, so to speak, right? And then the middle layer, which is sort of like the most popular ones in terms of the DevOps or the DevSecOps, so to speak, right? The new way of security. It could be like databases, messaging, the lifecycle management, the automation and the policy definitions, all of that. That's sort of like the layer that talks between the hardware and then the layer on top, that is the application. So that's sort of like the traditional middle layer, but it's a little not the traditional middle layer, but it's more of like an evolved middle layer, so to speak. And that is where the DevOps or the DevSecOps should definitely come in. And I am like a strong advocate of this, that the applications that's being developed should actually be the responsibility of the developer. You cannot expect DevOps to be in charge of crappy application logic and invalid boundary conditions that's been written or dictated by the developers, right? So the developers should be in charge of the applications to do the basic unit testing and the boundary checks and making sure that the code that they write is secure to some extent. The beefier implementations of security could actually be delegated down to this thing, but it's not that you write a shitty crap of code and then expect the DevOps to basically do it. No, that's not how it works. The developers should take ownership for the applications that they truly embed to make sure that the requests and the responses are sanitized and making sure that this is it. So this is how I see the stack of responsibilities being stacked up. And with that understanding and that benchmark that's been set in the delegation, let's look at how we can secure the container lifecycle, right? So now, what do you actually mean by a container lifecycle, right? There are various phases that's actually been involved. Starts with like a build phase, and then you ship the containers, and then the deployment that actually takes place, and then the final running or the application that's been running within the container. And the visibility is very much required to make sure that the security of the container lifecycle is throughout all of this, right? Because there are various amount of risk postures that's been completely which exist and which may not be completely understood. You are unsure as to where the security should come in, because as I said, it's like a very new way of doing things. And there are let's be open about it, because the visibility that's being provided to the containers does not exist even right now, right? Because and there's like a heavy emphasis on open source, and if a container or an open source project is basically just stopped maintaining, you could be left in the lurch, right? So these are all the risk postures that you have to have for the visibility across the spectrum. And now let's look at each of the specific ways in which, because the build is basically starting with the bundling phase, and it is very much important that the base images are secure and you scan for the vulnerabilities in each of them, right? Because that's the traditional way of not a tradition. When I say traditional, the most basic way of doing things in the containers, right? And you have to maintain this confusion standards, and this DevSec and ops have to share information. They cannot just live in silos. There has to be a coordination between the development team, the operation teams, and the security teams, which led to this phenomenon of DevSecOps, right? And you have to add enforcements to the image usage, and that comes in the shipment, right? In the ship phase, and you have to deny the unknown images. You need to have like an audit trail or a ledger of the images that could be accepted within the organization based on the risk categorization that definitely there. And this ensures that the integrity of the images are there. You can have automation to make sure that the checksums are basically checked against no checksum, and this adds the enforcements in terms of the image usage. And in terms of deployment, you have to basically, it's all about limiting the access to the container engine, right? Because, and how do you do that? You separate the automation from the human action. There's like a heavy emphasis on automation. I've told about it earlier in the previous slide as well. It's a new way of doing things. And you dictate the permissions that needs to be provided on the volumes and the networks, and maintaining an audit trail with the account of use. So this definitely makes sure that the control parameters are basically in check that could potentially elevate the privilege during the deployment phase. And running is not just about running the container, but the granular running of containers. And that is very important because you do the resource management and you have to protect the sensitive data that is residing. There are various tools like Vault, which is like a very popular one from HashiCorp that does this. And it's all about network recommendations that takes this. I'll touch that about the network segmentation specifically during the Kubernetes hardening later in the thing. But yes, you have to do some sort of like a network isolation to ensure security. So with that, I want to summarize the container aspect of it. And it all starts with the prevention of the unknown images. We have talked about earlier, this inadvertently stops the privilege escalation that could actually happen. And also it's about scanning for the suspicious processes, right? And how do you do that? How do you do this runtime thing? There are tools like Falco, which is like an open source project and part of the CNCF framework that actually done these processes monitoring while the containers are being run. So I highly encourage you to check that out. You enforce network isolation to do this, right? So you have segmenting the VPC segment, and you encrypt the sensitive variables and params. And this is being achieved by making sure that the parameters are being stored in the right manner. And you share by automation and tools, because there is definitely no humanly impossible to do this sort of a thing. And last but not the least, visibility, right? You can have the multiple environments that definitely exist, whether dev, QA, production or simulation and all the other things. And it is imperative that you understand what is happening across each of these environments, right? So with that, I want to shift gears and then go into the last part of this presentation, which is mostly focused about improving the Kubernetes security, right? And I want to touch base upon the various factors that I'll be talking about. So it starts with disabling the anonymous authentication, and I'm going to dive deep into each and how we can achieve all of these. So you start by disabling the anonymous authentication. You configure the admission controllers, which are very much a part of the Kubernetes cluster and the ecosystem, and specifically dive deep as to how the port security policies or the PSPs can definitely be used, which is again a part of once part of the admission controllers. Look at RBAC or the role-based access controls and how we can enable authorizations with it. And look at the network policies, which we can use to segment the ports and do a port isolation with it, right? So let's look at the anonymous authentication that we can achieve, right? So what exactly is it? There are generally two types of users that are definitely existing. There is the regular users that's been backed upon by entities like AD or LDAP. And then there are the service accounts that are managed by the Kubernetes API. Anything out of this is sort of like treated as an anonymous request, right? So with this understanding, we have this configure method that is definitely being passed to the API server to basically prevent any anonymous request. And just use this flag called anonymous authentication, just set it to false. By using it to the API server, you are explicitly denying any of the entries that is just coming outside all of this, right? So this is a very good practice and a recommendation that I basically recommend for disabling the anonymous authentication. The second one is basically configuring the admission controllers. And what exactly is it? Admission controllers are nothing but sort of like an interceptor to check for the create, delete, and modify request, or while connecting to a proxy, right? And there are multiple admission controllers that are definitely existing with this. Some of the recommendations are being given below. Definitely check out the resource quota and the port security policies that I'll be talking about earlier. But these are some things that should be enabled by default. And the syntax is very simple, right? You give dash dash enable admission plugins, and you specify the name of the admission controllers that are just being recommended. And I encourage everyone to dive deep into the Kubernetes documentation, search for these admission controllers, and then get the understanding. And another the one is the validating admission webhook. This validates the Kubernetes resources during the create, update, and delete process. And the other flag that I definitely recommend is the always pull images, because once this is being set, you have to make this basically sets and make sure that the private images are only pulled by those who have the credentials. Otherwise, when there is like an image update, if this is not set, the private images could actually be obtained by anybody. So these are some of the stuff that you should definitely check for the admission controls. Now let's dive deep into the port security policies, because I've wanted a separate discussion on this, although this was part of like an admission controllers, because they are very important, and it's beyond these 4 lines that I've just put over here. It's sort of like a condition for a port to be admitted in the system. Honestly, it is that, right? And the target port service account must be authorized for this policy. So when you enable the port security policy admission controllers, it basically just checks and validates the resources that are basically needed to ensure this admission. I highly encourage everyone to check this out, and it is sort of like an optional but a highly recommended admission control. And you can also disable the public access to the cluster. So this is definitely one thing that is there. You should never expose your remote connectivity to your node endpoint. Instead, you should rely on a Bastion host or a jump box to basically manage or access your management VPC. And you could establish it by peering for the cluster for the network connectivity to be reached, right? So this is another security recommendations that I highly encourage during the Kubernetes cluster deployment. And the other one is specifically with respect to RBAC. And how you achieve this is RBAC is sort of like an improvement over the traditional ABAC that existed with the Kubernetes 1.9. So, but when you migrate this from the ABAC to RBAC, make sure that the cluster admin role is not granted unnecessarily, because if you've been playing around with the Kubernetes prior versions, this would definitely be there, and it could actually be a potential mistake, because ABAC is a less secure version as compared to the more stringent RBAC mechanism. Because RBAC is all about regulating the access to the resources, which is based on the roles of the individual users, right? So that's sort of like a very powerful paradigm to actually play with. And it's sort of like another potential mistake is you have to prevent the duplicate role grants that could happen. So you inadvertently could roll multiple overriding roles that could basically rewrite your whole stuff, right? And do a periodic audit. I highly recommend that, because it is possible that you have subjects, that is people who would have left the organizations or the service accounts that are no longer being used. So do a periodic check to make sure that all of the subjects are pretty much valid and the RBAC is specifically associated with them. And then last but not the least, it's definitely the network policies that you have to look into for the Kubernetes cluster. And it's sort of like a little different, because the Kubernetes way in the traditional network, right? If everything is locked down by default, but in Kubernetes, pods are free to communicate with each other. So if you don't specify anything, then there is no isolation. Yeah, so that's sort of like understanding that I encourage everyone to build upon, because the pod isolation means that the pods are isolated if at least one network policy applies to them. So it's a little tricky to understand. So that's the reason why I've mentioned some network plugins. To definitely check out Calico and Romana and ViewNet. I personally would have worked with them. I'm not sure about the Cilium and the Cube router, but do check it out, and it would help you grab the understanding of the network isolation much easier by using these network plugins. So with that, I want to conclude, and not just for the Kubernetes security, but generally for security in general. And think of security, which is like very early and early in the life cycle. and you have to anticipate for future growth, because it's no longer about a layer on top. Gone are those days, right? You have to have the security embedded into each of the every method of the SDLC lifecycle and at each stack. So that is definitely very important. And you have to have that organizational buy-in from the people, because ultimately it's the people that actually makes it, and security is only as good as the weakest link in anything, right? So you need to have that logical and organizational structure which is very much defined to have this culture of security that is very much there. And this would enable and give the confidence within the teams to move fast and break things, rather than like a hindrance to achieve that, right? So security would give you that confidence to do rapid prototyping, so POCs, without even having the risk of failure, or without inadvertently exposing your sensitive data, right? And you should apply the security controls at the layer that makes the most sense. Now, when I say that, you doesn't mean that the security is ignored at the layers that is not making sense. No, that's not what I meant. You have to focus your resources at where the data is more sensitive, where there is like a more greater risk of penetration from the outside, and you can relax a little bit about the other non critical aspects of the infrastructure. So there are various ways in which you can classify your data. So you can, this classification would help you achieve there, right? So with that, I want to call it a wrap, and thank you all for listening, and I can open it up for any questions or comments. And this is like my handle to reach out. So definitely to check it out over there. All right.